Now we'll look at the create table in SQL Server. We use the create statement to define a new table in the database. So it specifies a table structure in terms of columns, the data types. Now previously we talked about data types and any constraints like primary keys, foreign keys, default values, and check constraints as well. So that will govern the data to be stored in the table. Now let's look at the basic syntax. So I'm going to just click on a new query here. And the first thing is to make sure that I switch to my database, to my demo DB. I think it's this one, so that I can actually use the schemas that are created somewhere there. Okay, so the first thing, let's look at structure. Actually, I needed to copy this. Now, here, this is just a basic structure of creating a table. So we've got create table with a table name, so which is the table or the name of the table that we want to create. In column 1, column 2, column 3, these are the names of the column, the table, and then the data type will be the data type, for example, integer or varchar or date that we talked about. And constraint is optional. It defines the rules for the data in the column, like we can say not null, or it's a primary key, or it's a foreign key constraint, or it's a check constraint. All right, let's do an example to create a simple table. So we're going to create a simple table called employees in the HR schema. So we will say create table employees. Okay, maybe we do not create it in the HR schema. We can actually create it as is. And then we've got parentheses. I'm gonna just go ahead and close the parentheses in case we forget. And then we can have the employee ID. Most of the time in the table, you always have the ID column. You start with the ID column, which is going to be the primary key. So we're going to have the employee ID, which is the type of integer, and it's also a primary key. Primary key. And then we can also put a identity there. I will explain identity in a moment. And then I think I keep on getting the wrong spelling. Identity. And then now we separate the columns with a comma. We separate the columns with a comma. So that my first column is employee ID, and then the second column will be maybe the employee name. So we can have employee name. And then employee name is going to take variable characters. So it's going to be varchar. And then we can also specify the length of varchar. Now looking at our data types, what's the size of varchar? So maybe we can say 255, and we can put a constraint and say not null, meaning this cannot be skipped. Whenever inputting data, you can't skip it. So that's our second. Then our third, we're gonna have maybe employee email. Our third column gonna be employee email, and then varchar, and let's say 255. All right, and then perhaps we close that with a semicolon, although it's not really necessary if there's no other script that you need to put or statement that you need to put in there. So now the employee ID is an integer value, or it's an integer column that serves as a primary key, meaning each value must be unique. and it cannot be null. There's a rule about primary key. It must be unique and it cannot be null. And then employee name is a variable character string with a maximum length of 255 characters. We know that there's no person on earth that has a name that has 255 characters. But you can shorten it sometimes. You can make it 50, 25. I mean, it depends. So, but again, it cannot be null. And then employee email, it is also a variable character string with a maximum length of 255 characters, but it can be null because we cannot, if we don't specify not null, by default it is null, it is nullable. So meaning you can skip it whenever you insert data. Now we can execute this and then we get the completion message. And then, okay, now the problem, this actually went to my database. I wanted it to be my demo DB. So there's a database that I wanted to use, and then I can re-execute. And then now we can actually look into my demo DB. Which is my demo DB. It has to be somewhere. And then, so under tables, we should have the table called employee. So that's a table that we just created. And then if we expand that by clicking the little plus there, we can actually see the columns, which is employee ID, and then the employee name, and then the employee email. So that's how we can create a table. Now, I just want to close my Object Explorer so that we can have more space. Now, suppose we have a table called departments. Remember, we already have employees. So what we can do, we can actually create, I think we can actually create a table, departments. So first, I think I'm gonna actually drop the table, table employee. I know it's there, so I will drop it and then recreate it again. And then I'm gonna create a new table called departments. Let's just type it in the correct way, departments. And then in here, I can have a department ID, which is an int. It's also a primary key. It's also identity. And then we can have maybe department name, and then we can have a variable characters. Let's just make it 100, and this cannot be not null. And then what I'm going to do on the table above, we can have now each employee will belong to a department, so we can actually create a relationship between those two tables, which is going to be one-to-many relationships. We'll actually talk about relationships a little bit later on. So meaning here, we're going to have the department ID that will link the two tables. So department ID, which is the int, and we can specify that this is a foreign key. Again, we'll talk about foreign keys a little bit later on. Foreign key, which is just wanna copy this, copy, and just paste it there. Foreign key, and then it references references departments, and then it references departments, but it references this column here, which is department ID. I'm missing a comma there, hence it's like showing as if like it's an error. It's actually departments. So the name of this table is departments. Sometimes you can just make sure that you you copy that. So the department ID is an integer column that references the department ID column in the departments table. So this, what it does, is establishes the a foreign key relationship between the employee and the departments. All right. So if we execute this, I've got some couple of errors. Foreign key reference invalid table departments. So I think we must just separate this like this, and we can run again. I suppose I cannot drop the table employee because it okay, let me just make it simple. I'm gonna say this one is employees, and then I'm gonna, because I already have the table, we will talk about altering the table later on, but we can actually rename it to employees, and then we create another table called departments, and we can execute. So I think it did create, because maybe I ran it twice. Now let's actually look what we have on the Object Explorer. So I will just refresh my database, and then we go to tables, and then we do have the departments and the employees. Now these two tables, they've got a relationship. I just want to see if I can't. Okay, I always struggle to create a diagram for some reason. But now if we expand this, then we can actually see the department ID. And then if we look into the employees, then we look into the columns, we can see the foreign key is actually facing upside down. So that's the key that we actually use to link the two tables to create date relationships. And then if we expand the keys, then we can see both of the keys. All right, so we can even add a table with, maybe suppose we want to create a table that will store product information with constraints on stock quantity. So what we can do, we can say create a table, let's say products, table products, and in that table we're going to have the product ID, which is integer, and is also a primary key, and then identity. Then we're going to have product name, which is varying characters, and okay, just make it 2.5, and then not null. And then we can have price, which is going to be decimal with a precision of 10 to 2, not null. All right, and then we have maybe stock quantity, stock quantity, maybe quantity, stock quantity, which is an int, and then we can put a default of 0. And then we can put the check constraint. We check if the price is greater than 0 and the stock quantity is greater or equals to 0. So if you check here, price, it must be greater. If you check here, the price is decimal column, that must be greater than 0. And then the stock quantity has a default value of 0, meaning if there is no value that is specified during the insertion, it will automatically be set to 0. And then the check constraint ensures that the price is always greater than 0 and stock quantity is not negative. So this is just the examples to demonstrate how the create statement can be used in SQL Server to define the structure of the table with different types of columns and constraints, and just to ensure that there is data integrity.